Hello. Today we are going to start or continue learning about Unit 7. Unit 7 is all about the mole. So what you should know to this point, you should know how to calculate molar mass. You should know what molar mass is. And if you do not know how to do that or know what molar mass is, please consult page 1 of your Unit 7 book. Page 1 has step-by-step notes that you can follow. And you can practice molar mass on page 2. Okay. You should know what a mole is. If you were in class, we watched a video from TED Ed. And so if you want to watch that video, again, it's a TED Ed video. I think it's the best way to Google search for it is just TED Ed. How big is a mole? And it'll come up. It basically just introduces you to a man named Avogadro and his number and how chemists use that as a way to package up really small molecules. So before we get going with Mole Island and actually doing mole conversions, I do want to quickly review with you percent composition in case you are not in class. Percent composition is just a way for us to know what the compound is composed of in a percentage form. And so anytime you see the word percent, you should know that that's calculated by part over whole times 100. So since we are working with a compound, the whole mass is just going to be our molar mass. And the part is going to be each individual element within the compound. So as a practice question, if you look at page 3 in your unit book, there's a couple of problems for percent composition. I want to look at the one for copper 2 hydroxide. So first we need a chemical formula. So copper 2 hydroxide, sorry about that. You'll notice that sometimes my slides switch when I'm not prepared, and I'm sorry for that, so just please bear with me. So copper 2 hydroxide, the chemical formula is OH2. If you do not know how to write that chemical formula, please consult Unit 5 for extra practice. So all we're going to do to start finding the percent composition is actually just find the molar mass, and you'll see that it's pretty beneficial to actually show your work. So for what we are doing, copper, there is 1 copper times 63.55, so that's giving us a mass of 63.55. For oxygen, there are 2 oxygens, and I'm going to multiply that by 16. 2 times 16 is 32. And for hydrogen, 2 times 1.01 gives me 2.02. If you're confused as to why there's only 1 copper and 2 oxygens and hydrogens, this 2 can be distributed in, but the parentheses tell it where to stop. Okay? So again, all of this step that I have done is you're able to follow along with it from page 1. So that helps me find my molar mass is 97.56. So in order to find the percent composition, all we're going to do is divide part over whole times 100. So my part for copper is going to be 63.55 divided by the whole, which is 97.56, times 100, and that gives me 65%. For oxygen, I'm going to do 32 divided by 97.56 times 100, and that gives me 33% oxygen. And hydrogen, last but not least, 2.02 divided by 97.56 times 100 gives me 2%. I always just round those up to a whole number. It's a good way to check yourself. They should add up to 100 or close to 100, but remember, we have rounded. Okay, so if you would like to practice percent composition more, finish page 3 of your unit book. You can also go back and work any of the problems on page 2 and just find the percent composition of those. So moving forward to Mole Island. Mole Island is going to be your guide to mole conversions. So what is Mole Island? How do I use it? We're going to start out by drawing a picture. Okay, so I'm going to have Mole Island in the middle. Okay, I'm going to have Things Island, I'm going to have Graham Island. And down here, I'm going to have liters of gas island. Okay? So, we use a mole as a conversion factor, just like we know that there are 3 feet in 1 yard. We know that there are 60 seconds in 1 minute. We know there are 24 hours in 1 day. Okay? Those are all conversion factors that we have had memorized since elementary school. Now, because a mole is a new unit to you, we use Mole Island as a way to help us visually represent our conversion factors. So, the first thing that I need to know about Mole Island, see if I can change the color of my ink down here. 1 mole is going to be equal to Avogadro's number. Avogadro's number is 6.02 times 10 to the 23rd. So I have a direct way to convert from units of moles. And then things is pretty vague. So what I mean by things, typical units, atoms, molecules, particles. You'll see formula units. The TED Ed video will tell you could have a mole of basketballs or a delicious mole of donuts. Okay, you can have a mole of anything, and that's why the units that I use in the Mole Island are kind of vague. So 1 mole is equal to 6.02 times 10 to the 23rd. Okay, next, 1 mole is equal to the molar mass. That's right. All that I made you do on page 1, 2, and 3, the molar mass, is going to be used as a conversion factor. So remember, in order to find that, you have to look at the periodic table. You actually have to do a little bit of work for that part. Okay, the last section down here, liters of gas, and this is going to be at STP, standard temp and pressure. Those conditions are just 0 degrees Celsius and 1 atmosphere. Okay, so at STP, we can use the conversion factor 1 mole equals 22.4 liters. Okay, so what I would do now is pause the video and you all copy Mole Island down on a separate sheet of paper, or you can keep it out in front of you and look at it as we're working every problem, because this is what we're using. This is where all of our information is coming from. Okay, I also want to emphasize, if you look at Mole Island before we move forward, every branch has 1 mole equal to something. So that's helping us set up our conversion factors. Okay, first practice problem I'm going to work is on page 4 of your Unit 7 book. So anytime I work a word problem, I like to underline what I'm given and what I'm given to start with and what I'm ending with. So the problem says, how many moles of magnesium is 3.01 times 10 to the 22 atoms of magnesium? So I read the problem and I see moles is what I want to end with. Those are the units that I want. And I'm given 3.01 times 10 to the 22 atoms of magnesium to start with. So I'm going to look back at Mole Island really quickly. I'm here on Things Island, and I want to get to Mole Island, and so I can see that that's a direct relationship. I have a direct flight. So what I'll do is I'll just draw that part of the island for us. So I have things, I have moles, 1 mole equals 6.02 times 10 to the 23rd. Okay? So I'm going to start with what I was given to start with, which is 3.01, sorry about that, times 10 to the 22 atoms. And I'm going to go ahead and label that I have magnesium. 3.01 times 10 to the 22 atoms of magnesium. It's going to get me in a good habit for stoichiometry. Now, my units are atoms of magnesium, but that's not what I want. And so in order to get those units to cancel, I'm going to need to divide by them. So in order to divide by moles, all I'm going to do is put it on the denominator. So atoms sorry about that, of magnesium goes to the bottom. And because I have a direct relationship, I can go from things to moles, and I can convert directly to moles of Mg on top. So now, when it comes to filling in my conversion factor, this is where I'm looking. 1 mole is equal to 6.02 times 10 to the 23rd. Well, here's the word mole, so a 1 is going to go next to it. 1 mole is equal to 6.02 times 10 to the 23rd atoms. Okay? Now, in order to plug and chug into our calculator, we have to figure out if this is a multiplication or a division problem. Okay? So, this is going to be a division problem because the number is in the denominator. I have 1 over 6.02 times 10 to the 23rd. So when you plug and chug into your calculator, your correct answer with the correct number of sig figs should be 0.050 moles of Mg. If you do not remember what a significant figure is, sig figs are covered in unit 1. So feel free to go back and review sig figs because they will never go away. Okay, so that is your official first mole conversion problem. All right, let's look at another. How many molecules are there in 4.00 moles of glucose, C6H12O6? So I'm going to underline what I'm given to start with. I have 4.00 moles of glucose to start with. Sorry about that. And I'm going to go to molecules. So again, that shows me that I'm here on this section of Mole Island. Things and moles, except this time I'm going from moles to things. I'm still using 1 mole equals 6.02 times 10 to the 23rd. So when I set up what I'm given to start with, 4.00 mole of C6H12O6. I don't want moles, so I put that unit on the bottom. And now I'm going to convert up to molecules. A mole and a molecule are not the same unit. They might look alike, have the same couple letters, but they are not the same. Okay. When I fill in my conversion factor, 1 mole, that's on the bottom this time, and I'm going to have 6.02 times 10 to the 23rd molecules. So this time, this is going to be a multiplication problem because my number is in the numerator. So when I multiply and use correct sig figs, I have 2.41 times 10 to the 24 molecules of glucose as my answer. Now, your calculator probably says 2.41 with lots of other decimal places, e to the 24. E to the 24 is calculator language for times 10 to the 24. Okay? So what I want you to do now is pause the video, and I want you to finish 3, 4, and 5 of that section. When you finish those problems, press play again, and I will happily go over the answers. I'm not going to actually work the problems out, but you can see if you can check your answers, see if you got them right. Practice, 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 practice. All right, so you have finished 3, 4, and 5 of that next section. And the correct answer for number 3 is going to be 19.9 moles of phosphorus. The correct answer to number 4 is 4.515 times 10 to the 23rd atoms of zinc. And the correct answer to number 5 is 2.41 times 10 to the 23rd molecules. All right, so again, in that section, we strictly went from Mole Island to Things Island. It was one step. All right, next up, how many moles, next section, how many moles are in 28 grams of CO2? So I underline what I'm given to start with. I have grams of CO2 to start, and I'm going to convert to moles as my final units. Now, this time I'm not using Avogadro's number anymore. If I flip all the way back to my original Mole Island, here we go. This is the section of the periodic table I'm interested in. It gave me grams. I'm going to moles. So you can very clearly see I'm on this path here, back and forth now. So I'll redraw that on my slide over here. So gram, sorry about that, gram to mole, and I know 1 mole is equal to the molar mass. Okay, so I'm given 28 grams of CO2 to start with. I don't want grams of CO2 so to get those units to cancel, I needed to divide by them. So grams of CO2 goes to the bottom, and I'm going to convert up to moles of CO2 on top. Now, here's my conversion factor. 1 mole equals the molar mass. So I have my 1, but now we actually have to do a little bit of work to find the molar mass for carbon dioxide. So this is where you use page number 1. The molar mass of carbon dioxide, 1 times 12.01, 2 times 16, is going to give you 44.01. I'm not going to show you where that calculation comes from every single time. That's something that we expect you to know how to do right off the bat. Okay, so 1 mole is equal to 44.01 grams of CO2. This time we are dividing, so 28 divided by 44.01, that's going to give you 0.64 moles of CO2 as your answer. Sorry about that. Okay. All right, flip over, next page, page number 5. Let's look at number 2. Number 2 says, what is the mass of 5 moles of Fe2O3? Okay, so I underline what I'm given. Okay, now it says I want mass, but remember, mass is not a unit. Mass is what we're measuring. So the unit of mass that we are interested in is a gram. That's what we mean by mass there. Okay, so here I am again, gram island to mole island. And in order to go back and forth, I know 1 mole is equal to our molar mass. So 5 moles of Fe2O3. Hopefully you know that that's iron 3 oxide. I do not want units of moles, so those unit goes to the bottom. Moles of Fe2O3. And I'm going to convert to grams of Fe2O3 on top. So again, mole island tells me that 1 mole is equal to the molar mass. So 1 mole, and my molar mass of iron 3 oxide, I have 159.69. Oh, sorry. Okay, and my final answer here gives me a big number, 798.435 grams. But I want to point out that this has 1 significant figure, and so I need to round this to 1 significant figure. So you have a couple options. You can use scientific notation, 1, 2, so 8 times 10 to the 2 grams, or you can recognize that that's the same thing as 800 grams. Both of those have 1 significant figure. All right, you're up next. I want you to go ahead and finish page 3, 4, and 5 of that section. Remember, there's no way to get good at math or get good at chemistry unless you actually do it. So please get as far as you possibly can. Show all of your work, and if you need extra help, you can come see one of your chemistry teachers in person. So please go ahead and pause the video and work on 3, 4, and 5 of that section. Okay, so let's go over the answers. Number 3 is going to be 11.3 moles of argon. Number 4, the correct answer with significant figures is going to be 0.00757 grams of HC2H3O2. Hopefully you recognize that you could put this into scientific notation as well. 1, 2, 3, 7.57 times 10 to the negative third grams. Those are the same thing. And last, number 5, the correct answer the problem gives you 225.80 grams of LIBR as your answer, but it only gave you 2 sig figs. So when I round this to 2 sig figs, that's going to be 230 grams of LIBR, or you could put this into scientific notation, 2.3 times 10 to the 2 grams. Okay, hopefully you got those right. And if you didn't, please feel free, as long as you have shown your work, one of your chemistry teachers can show you what you did wrong. All right, last step. Determine the volume in liters occupied by 0.030 moles of a gas at STP. So here's where I'm starting, and here are my ending units, start and end. So this time, if I flip all the way back to Mole Island, my original Mole Island, my new section that I'm in, I'll change my color so that we don't get all confused here. Here's my last section that I'm interested in. I'm going from moles to liters, and so I'm using 1 mole is equal to 22.4 liters. So I'll draw that section on our paper. Moles to liters of gas. 1 mole equals 22.4 liters. Now remember, it has to be at STP. Your problems will either tell you to assume STP or not, and so then you can use your conversion factor, no problem. So 0.030 moles. I don't know what the chemical formula is. It just says of a gas. So I don't want moles, so those go to the bottom. I'm going to convert to liters on top. 1 mole equals 22.4. So my conversion factor is 22.4 over 1 this time. This is a multiplication problem because I have the number in the numerator. So when I multiply and round with sig figs, the final answer is going to be 0.67 liters of gas. All right. One more example for all of us. How many moles of argon? So here's what we're ending with. Moles of argon atoms are present in 11.2 liters of argon gas. So again, I'm only staying in one-step problems. 1 mole equals 22.4. 11.2 liters of argon. Liters of argon to moles of argon. 1 mole, 22.4. This time we will divide, and so with the correct number of significant figures, 0.500 moles of argon. So remember, you have to show your work. Your answer has to have the correct number of sig figs and also units. If you don't write units, it's automatically wrong. So to finish practicing one-step conversions, you finish 3 and 4 of that section. And then in the next video, we're going to do multi-step mole conversion. So we're going to use mini islands from Mole Island. Thank you for watching.